Good morning, students. So we are doing chemical bonding chapter, right? Okay. So last time what we did was all those structures we had done, right? Chemical bonding. Okay. So today, students, although you have done this in NCRT, right? Okay. We'll study some properties of molecules. Some properties, like what do I mean by properties? So molecule will have bond length, right? Like for example, this AB bond, like okay, bond length. What is bond length? The distance between the nucleus of A, right, and the nucleus of B. That's called bond length, right? This is A, right? So A overlaps with B, correct? So this distance we call it as bond length. Okay, fine. So this distance, this is a nucleus, this is a nucleus, right? This is what is called bond length. Okay, of this bond AB. Fine. Now, this bond length is very important, students. If this bond length is very less, it's obvious that the bond is very strong. Okay, smaller the bond length, right? The atoms are coming very close. The bond is very strong. Let's take some examples now. Let us take an example like HH, right? Okay, ClCl. Okay, so here which bond is stronger? Yes, obviously HH. Why HH? Because the atoms are very small. Okay, very small atoms, right? Very strong bond. Fine. Now, students will do some questions. That's more important because theory part anyway. You have done it, right? In NCRT, you have done it. Okay. So now some questions will come to you like this. Like suppose FF bond is there. Okay. ClCl bond is there. Fine. Now we expect that FF should be very strong. Why? Because F is very small. Listen is very carefully. This is some differences there. Like we expect that FF should be very strong bond. Okay. Because the size of fluid is very small. So it should be very strong. But when people have done experiments, they have found that ClCl bond is strong compared to FF bond. Okay, let's see the reason now. Or in other words, the ClCl bond length is very less compared to FF. Okay, now the answer lies here. In case of FF, I'll just write in the next, like what happens is F has got 9 valence electrons. Now, students, listen to this very carefully. This F has also got 9 valence electrons, right? So what will happen now? Total you will get 9 plus 9, you will get 18 electrons. Huge number of electrons, remember. Total is 18. You will have 18 electrons, right? And the space is very, very small. Fine. So in that small space, please remember you have to accommodate how many electrons? Yes, 18 electrons you have to accommodate. Okay. So lot of repulsion. That will be like huge repulsion will be there. Right? See 18 electrons, small space. They will repel. Because they have the same charge. So due to that repulsion, this bond becomes weak actually. So this bond will break easily. Clear? Break. That problem will not be there for ClCl because Cl is quite big. Though it has more number of electrons, I agree with you, right? Yes, more number of, but this, space is very high because Cl is a big atom, right? It's quite big compared to fluorine. Okay. So that's the reason why FF bond will break very easily compared to ClCl bond. Fine. Okay, students, this is main thing. So this problem will be there for fluorine, right? Okay. So next thing, students, bond energy. What is bond energy? Tell me. The energy required to break a bond. Let me give you some examples now. If you see N triple bond N, The energy required to break that bond, right? Or there are other names also for this bond dissociation energy, right? Okay, fine. So many names are there. Now it will require a lot of energy to break this bond, student. Why? Because, okay, I'll write again. Okay, a lot of energy is required. Why? Because the triple bond, remember, and triple bond is very strong. Okay, a lot of energy. Even if you take carbon single bond, carbon double bond C, carbon triple bond C, right? You will see that this triple bond is going to be very strong. Require a lot of energy. That is what is called bond energy. Okay. See, during any reaction, you have to break bonds, right? You have to form bonds. Okay. That's all a reaction is about. Clear? So triple bond, very strong bond, right? Same thing will happen here also. Fine. So this is what is called bond energy. Okay. Then comes bond angle. Okay. Bond angle, right? Now, if you see bond angle, students, you know that lone pairs will affect. I think that we have done. Like, so for example, ammonia, correct? You have got a lone pair here, correct? So actually, the bond angle should have been how much? 1 knot. So I'm discussing the important ones here. 109.5. You expected that, right? Tetrahedral angle. But then here you get a bond angle of only 107. Only 107, right? Why? Because this lone pair will repel this bond pair, right? So your angle will come down. Same thing will happen for water also. In fact, water, students, you'll have more repulsion. You see, there are two lone pairs, right? How many? Two lone pairs, right? So this will also repel. This will also. This will be a lone pair repulsion also, which is going to be very big actually. Lone pairs, they repel the lone pairs very strongly. So they'll take a lot of space, lot of space. His angle will come down like anything. So it will be around 104 or 104, 4.5, whatever. Okay, fine. 104, like 12. So because of LP, the angle will come down. So all these questions, they can ask you in the exam. Like why, arrange them in the order of bond angle, right? That's the problem. So because of this repulsion problem, right? Okay. I'll give one very interesting thing. This is, like the most important thing here. Suppose in exam they ask you H2O versus F2O. This is the question, right? And the question is which has got more bond angle. Very important. Okay. See, in case of H2O, lone pairs are there, students. Lone pairs will be there here also. Lone pairs will be there also. Lone pairs will not, will not create much problem, right? Okay. Now, in case of H2O, what happens? Oxygen is electronegative, right? So it will pull all the electrons towards itself. Binary electronegative. Will pull all the electrons. Hydrogen electropositive. So what will happen? You will have overcrowding of electrons here. Correct? Yes. Lot of overcrowding. All the electrons will go towards oxygen. So therefore, you will have lots of electrons. So this bond will slightly try to open up. Okay? To minimize that overcrowding. ரொம்ப கூட்டமா இருக்கு. Tamil what do you say? ரொம்ப கூட்டமா இருக்கு electron. Bond will try to open up. Okay? So here, we already discussed 104. But here that problem is not there because here the fluorine, listen here. Fluorine will take away all the electrons. Fine? So you will not have any overcrowding here. So no overcrowding. Listen here very carefully. Yes. No overcrowding. So another bond angle will be slightly lesser. It will be actually 102. I think people have measured it, right? 102. So A will have, students, A will have more bond angle compared to B. Is that clear? Why? Thanks to the electronegativity of oxygen. All electrons and bond will slightly try to be, you know, bigger. Bond angle is bigger. I hope you're getting this. So in terms of bond angle, A will be greater than B. Okay. Then I'll give you one more very interesting thing. I will take in the next page, right? Suppose they give you water, ethyl alcohol, ether, A, B, C. Now see here, A, B, C, right? Arrange them in the order of bond angles now. So when you arrange it, you have to know that the C2H5, remember, is a quite bulky group. கொஞ்சம் குண்டா இருக்கு. Okay. Here you have got, sorry, one small mistake I've done here. 1 minute. Okay. Yes. Let me take like this. OC2H5, C2H5. Just see now. Now here you see C2H5 is slightly big in size. Okay. So this angle will slightly increase. This angle I'm saying, right? Slightly increase. Here you will find even more increase. Why? Because you've got two C2H5 groups. Very clear? The C2H5, will occupy more space. More space, right? So angles will increase. So what is the order of bond angles? The order of bond angles is, okay, C will be the highest, followed by B, followed by A. Okay? I'm sure this is due to the huge size of C2H5 group. So they can ask you this question also. Fine? Very big size of C2H5. Can you please note down this in your book? Right? Okay. So bond angles, see, if a question is asked on bond angle, you should consider three things. One is that lone pair effect. Second is that electronegativity effect, right? Okay. See, first effect is what? That lone pair effect, right? Second is that electronegativity effect. And third thing is this size effect. Based on these students, you can do any question in bond angles. Very important. Lone pair, electronegativity effect, and size. Size effect is also called students steric effect in chemistry. They also call this as steric effect. Okay. Fine. My students start, right? So based on these three, you can decide what is the bond angle, all these things. I'll give you some more questions now. This, you'll be able to get better. Suppose I say CCl, this bond, and suppose I say, I'll ask you a question. Suppose I ask you which bond is strong, which bond angle is higher. Okay, A, B, C. Now you will see very simple. This you can decide based on size effect. You see, bromine is very big in size. Alright, bromine is very big. So therefore, what will be the order of bond angle? Tell me. The order of bond angle will be the order of bond angles, right? will be what? C will be the highest. Bromine is very big. Getting it? C will be very big. No, the angle will be because bromine size is very big, right? This will be out of bond. Okay. So depending on the size. Okay, students, I hope you are getting it. Okay. Now I will tell you a very important concept, some exceptions. Now in ammonia, students, you are getting the bond angle as 107. This is something very interesting. Then the same family, nitrogen family, you have got phosphorus. Phosphorus, same family. What are the elements of that family? Tell me: nitrogen, phosphorus, arsenic, antimony, and bismuth. Nitrogen, phosphorus, arsenic, antimony, bismuth, right? So I'm drawing pH 3 now. Now, very surprisingly, what scientists have found is this angle comes out to be somewhere around 93. 93. Somewhere around 93. 93, 94, right? Such a drastic change they are finding. Okay. Now, if I draw ASH3, suppose you take ASH3, right? Again, lone pair will be there, students. Lone pair will not go anywhere. Okay. Yes. Now, this angle they have come to be around 91. Arsenic. Okay. And if you take antimony, lone pair will be always there. Like, yeah. This angle comes to around 90. And for BIH3 also, this angle is close to 90. Close to 90, right? Now, this was very surprising because you can't see such a drastic change. 107 to 93 means something serious, something very serious is happening here. Okay, lone pair repulsion, okay, fine, everything okay, fine. But not such a big change, like, yeah, fine. So there is some drastic change here. Now, what is happening here? What is the hybridization of nitrogen? sp3. Fine. sp3. Now, in these four molecules, students, where you are getting very close to 90, please listen very carefully. You are getting very close to 90. You can't have sp3 hybridization. sp3 hybridization means you should have close to 109. 109 close means 104 okay, 107 okay, not less than 100. Clear? So it will be sp3. Fine. Okay, very close to 109. If you get it is sp3. Remember, you can decide the hybridization by the angle also. Okay, so here okay, sp3 hybridization, fine, done. But here definitely it is not sp3. These four molecules, they are not doing sp3 hybridization. Okay, what is happening there in these four molecules is also close to 90. Like close to 90. In these four molecules, the p orbitals are doing bonding. P orbitals are involved in bonding. There is no hybridization. The three p orbitals are there. Na? Those three p orbitals are forming three bonds. Simple. P orbital of phosphorus with the s orbital of hydrogen. See, p orbital, s orbital of hydrogen. P orbital of phosphorus, right? S orbital of hydrogen. P orbitals. Why? Why? See, you have three p orbitals, right? Px, py, and this is px, this is py, right? This is pz. Okay. What is the angle between them? Tell me. 90 degree, right? The angle between each one of them, they are all lying in x, y, and z, right? 90 degree. Okay. Here also you're getting 90 degree, very close to 90. That means, clear? Let me repeat. P orbitals, angle is 90. Here also 90, close to 90. That means here the p orbitals are doing the bonding. One bond is formed due to the overlap of px orbital. One bond is formed due to the overlap of py orbital. The other bond is from overlap of pz orbital with the s orbital of hydrogen. S orbital of hydrogen. Is that clear? So how are you getting the bonds here? Px with the s orbital of hydrogen. Let me write here Py with the s orbital of hydrogen and Pz. Okay. And student, that is the reason why you are getting 90 degrees. Fine? Because the angle between these three is 90. It's very important. Okay. Students, please note down this very important point. Okay, students, have you noted down this? This is something very, very important, right? This happens for the nitrogen family, especially for only the nitrogen family, right? Okay. So it's all about bond angle. Bond angle. Students will come to this property dipole moment. Okay, mu. What's the symbol? Mu, right? We will directly do some questions on this. We do not go into the theory of this, right? Suppose I ask you a question like this: calculate the mu value, right, for HF molecule. Let me give you HF molecule, right? I will give you the bond length. R is 1 angstrom. Okay, R is 1 angstrom, and the charge is Q is equal to, okay, 1 points. Okay, I will give directly that value, right? Okay, this is the charge. (3.2 into 10 to the power minus 20 coulombs, right? Fine. So I have to find the dipole moment now. So what is the formula, students? Very easy question. Like this will not take much time. Mu is equal to Q into R. Okay. So that's very easy answer. Like yeah, Q into R. Now, students, you have to convert this Armstrong to meter. Please remember that is one thing you have to do now. What is 1 Armstrong in terms of meter? 1 Armstrong is how much? 10 to the power minus 10 meters. Please remember this is very important. Yeah. So we have to write that in meters. So what is the answer? 3.2 into 10 to the power minus 20, right, into 1 into 10 to the power minus 10. Okay. So the answer will be how much? 3.2, 10 to the power minus 30, right? Coulombs meter. Okay. This much coulombs and then multiply by the distance, right? So this is the answer. 3.2 into 10 coulomb meter, right? Okay. Now students, you have to change this to device. Now this looks like a very big answer, right? So one debye, there was a scientist called Debye. He told that one debye is equal to 3.33, right, into 10 to the power minus 30 coulometer. Yes, 30. Okay. So give your answer in device now. So if we give a device, I think the answer will be mu is equal to 1 debye is this much. So 3.2 by 3.33, right? Into 10 to the power. This 10 to the power minus 30 will cancel, student, right? So you'll get in device. You'll get approximately 1 debye. You can say 1 d. Mu is equal to 1 d. Correct? You will get 1 debye. Fine. So you may get a question like this, students. Very important. It's not very difficult, very easy question. You just have to substitute and get the answer, right? Okay. Fine. Okay. Now, more importantly, this is an easy question. More importantly, they will ask you, this has been asked in NEET exam. Suppose I give you a molecule like this, HF. You may take the same molecule, no problem. Okay. This will have some charge. Some small plus charge will be there, some small minus charge will be there, right? Suppose if I give you the charge, okay, can you tell me like what is the percentage ionic character in the molecule? Okay. Suppose I say the charge is 0.2 times of the electron. Electron, remember, has got charges how much? 1.6 into 10 to the power minus 19. That's a basic charge. So 0.2 times of that. Clear? Then what is the percentage ionic? That means this bond is how much ionic? You have done in theory, right? How much ionic? So in that case, your percentage ionic character will come out to be 0.2 into 100. Clear? Percentage, na? So 0.2 into 100. How much it will come? 20% it will come. Clear? So you have to get the charge in terms of electron. Basic charge. Clear? 0.2 times electron. Suppose you get one electron, suppose you get the charge as directly one electron, then it is ionic. Like for example, Na plus Cl minus, you see, full charge is there, full charge. In this case, this bond is ionic. In that case, the bond is 100% ionic. Clear? 100% ionic. Because you're getting full charge, right? This bond will not be completely ionic, remember. But yes, some ionic character will come there. Why? Because chlorine is electronegative. You have done this. Chlorine is it will pull the electrons, right? So you'll get a slight negative sign, slight positive sign. Fine. So it will develop some ionic. It will develop some charge actually. Charge is nothing but ionic. Okay. Charge is ionic. So here, how much charge you are having? 0.2 times. So 20% ionic character. Fine. Suppose the charge comes out to be 0.3 times of the electron. Listen to this. 30%. So you can have 30%, 40% ionic character. Okay? If you are getting 100% means it is NaCl. Okay, students? Fine. We'll do a sum on this now. We'll do a sum on this, right? It's the last thing we'll do now. We'll say calculate the percentage ionic character in HF molecule. Okay. I will give the distance. Distance is 1 angstrom. 1 angstrom is how much? Distance is 1 angstrom, right? 10 to the power minus 10 meters. Okay. And the dipole moment I will give you. One divide. I suppose I say one divide, right? That's mu. Okay. Dipole moment is one divide. So student, just apply the formula now. Mu is equal to Q into R. Correct? Dipole moment is how much? 1. 1 divide. But 1 divide, student, is how many coulometer? Yes, mu is equal to Q into R, right? 1 divide is how much? 1 into 3.33 into 10 to the power minus 30. Remember, we have to convert this to this. I just now told you 1 divide is equal to, okay? Yes, charge. Now this charge, student, you write in terms of electron. Write in terms of electron. Let me write A. A into 1.6 into 10 to the power minus 19. In terms of electron, you're writing A into. So we'll calculate A. And what is R? 10 to the power minus 10. Getting it? We're writing in terms of the electron. Fine? So if you solve this, you will get very close to zero point 0.2. Just check A is equal to, this will get cancelled, this will get cancelled, right? You will get 3.33. Fine. 1.6, right? Just check it out. No, there will be a, let's check it out. Minus 1 also will come. Why? Because this 10 to the power minus 1 will still remain here. Okay. So this 2 and it will come very close to, 1.6 into 2. It will come to very close to zero point 0.2. Just check it out. Just check it out. Okay, 10 to the power minus 1 will remain. So in terms of electron, how much is the charge, students? Point 0.2. Yes. Clear? You will get in terms of electron 0.2. So 0.2 means the percentage annihilator, just now I told you, just multiply that by 100. So you'll get 0.2 into 100, right? You'll get 20%. That's all. That's how you find percentage annihilator, right? Okay. So students, you have to tell in terms of electron. In terms of electron, 0.2, right? 0.2 times of the electron, 20%. Okay. Okay, student. So I hope you are getting it right. So I think we'll wind off for now. Fine. So please do some sums on this, right? Okay. Okay, then bye. See you. We'll meet next time, right? Fine.